Static equilibrium 3. Let's do a couple more beam problems. Again, we're going to consider the beam weights as negligible, and we want to find the support reactions, which I'm going to call RA there and RB. So when we say support reactions, we mean the forces that are holding this thing up at each of those points. To satisfy force equilibrium, the ups have to equal the downs. So I've got RA and RB acting upward. And then how much do we have downward? 200 plus 410 plus 190. That's going to be 800. Now we need to put in an imaginary pin somewhere, an imaginary hinge, if you will, and we should put it above one of the unknowns so that that unknown doesn't appear when we write our torques equation. And so we have a choice. We could put it above RA or we could put it above RB. Let's put it above RA because then when we do the torque equation, not only will RA not appear, but this 410 will not appear. So that should make our lives easier. All right, so let's sum the torques now. And that means we're going to need to consider this 200 Newton force, RB, and the 190. The 200 Newtons is having a lever arm here of 2 meters. So let me write that in, 200 times 2 meters. RB, I won't put a plus or minus sign yet. We'll do this slightly differently. RB has a lever arm. Remember, everything is measured relative to this imaginary pin. So that's 6. And then 190 has a lever arm of 10. Now, in what direction do these torques act? If you imagine that this pin is fixed here, the 200 Newton force, if it had its way, with this pin fixed in place, would cause the rest of this beam to rotate counterclockwise. What about RB? If RB had its way, and this is a fixed point here, RB would push the beam also counterclockwise. What about the 190? The 190 would cause this beam to rotate clockwise, wouldn't it? So that tells me that these two guys are on the same side of the equation as each other, and that one is on the other side. Let's do a little work here. This is going to be 400 plus 6RB, and that's going to equal 1900. We can solve this then for RB. I trust that you can solve that. Actually, maybe, can we do that together? Subtract 400, that's 1500 divided by 6, 250. 250 newtons. That's what RB is. And therefore, from our first equation, if RB is 250, then RA must be 550. There you go. That's how you do it. All right, let's do one more. The ups equal the downs. Let's put our reactions in there. There's RA. There's RB right there. Let's do the ups equal the downs. Looks like, ooh, we need to be careful here. Look at that. That 800 Newton force is acting up. So it's going to be on the same side of the equation as RA and RB. Here we go. RA plus RB plus 800 equals, now what's coming down? 1500 and 2000. So that's 3500. Why don't we simplify this equation? We can subtract 800 from both sides. In effect, we get RA plus RB is equal to 2700. All right, so just be careful that you don't get tripped up if we've got a point load here going the wrong way. All right, so now let's sum the torques. Where do you want to sum the torques? You want to sum them about point A or point B? Let's do point A. So we're going to pretend that there's a pin right there. And let's see who goes where. So we're going to go 1500 times 2. We'll put the directions in just a minute. We got 800 times the lever arm is 5. We've got RB times a lever arm of 7. And then we have 2000 times a lever arm of 11. All right, what does that give us? Which way do these torques go? This 1500 Newton force, again, the pin is fixed at the left end. That would cause this thing to rotate clockwise. The 800 Newton force would cause it to rotate counterclockwise, as would RB times 7. That would cause this thing to rotate counterclockwise. How about the 2000? That would cause it to rotate clockwise. So in other words, these two guys are on the same side of the equation, and they need to equal those two. Running out of room here. Can you solve that without me writing it down? We would have to take 800 times 5 plus RB times 7. That would be on one side of the equation, and all this would be on the other side of the equation. When you do that, you get RB equal to 3,000. Now, if you put 3,000 then into our force equation, what does RA come out to? RA comes out to be negative 300 newtons. Now, what's going on with that? All that means is RA doesn't point up. See, in our picture, we thought, yep, RA points up. You know what? It doesn't. It needs to point down. We actually need to hold this end down to keep it from rotating, because you see you got this big boy here on the end, 2000, trying to make this thing rotate clockwise, and we need RA to actually be pulling down on this end. So to finish here, one reaction was different from the others, and why is that? Well, it was negative, and all that means is that that reaction acts opposite the way we thought it did.